I will share my screen. I believe you guys can see my title screen. Confirmation on that?
Yep, we see it.
Very good. All right. So as Mark mentioned, I'm going to be talking about using Clojure with GitHub and to solve some problems and who I am. As you mentioned, my name is Tom Cooper. I'm a chief architect at Frontline Education. And just to learn just a little bit about me, so you know like where I'm coming from in this world here. I started my journey at Digital way back, and I was in the AI groups, and I was in expert systems and knowledge engineering and hardware configuration, things like that. And if you're familiar with the history of expert systems, you may know about the R1 system or the XCon system. I was on the ground floor as part of that. And that's where I started my career, and then went into electronic design automation software and simulation things with ViewLogic, which became Synopsys, and then moved from there. Actually, I moved from there to a company called NobleNet, which was doing distributed system RPC and other kinds of tooling to connect systems together. I then went to RogueWave, which immediately spun off a Fornova division, which was doing internet-based procurement documents. And that then folded me back into RogueWave, working with C++ and working with the experts in RogueWave, which I learned a lot about how to write libraries and how to write code that you don't know who's calling it, which these guys are really good at. And from there, I went into Workscape, which got me into HR software, into compensation management, benefits administration systems. And there that led to an acquisition by ADP. And in 2010, I entered ADP, and there I was a chief enterprise architect among several other chief enterprise architects, overseeing the worldwide ADP kind of architecture space. I left that spot and joined Frontline in 2016. And Frontline is where I became the chief architect there, looking at building up a distributed system and multiple applications up. Frontline itself serves the K-12 school districts across the country. Before I jump into that, I'll just mention, looking at like what my journey has taken me through. These are the languages which I used in rough proportion to the amount of time I developed them with them professionally. I always did lots of tooling and other things, Ruby and Perl and all kinds of other stuff. But these were the primary languages I used in that journey. When I entered Frontline, so Frontline Education is a company that serves K-12 school districts across the country. We're in like 12,000 school districts with our products. We have a suite of products. And the important thing here is really setting us up is over the years, Frontline has grown through acquisition. And this is a history of, in the last so many years, about the different companies that we acquired in the education space. We are helping school administration, and we're not in the classroom. We're not teaching kids or providing materials or curriculum. We're really helping districts run their schools as a business, and with their employees, and to recruiting and professional development of their teachers and such. We also help them meet state requirements around special education and different kinds of plans. So, so all that I say, that leads to the fact that we have a lot of different applications and code that we inherit from these acquisitions. We have about 20 some applications of our own, and then we got lots of other stuff we bring in, and we pull them in, and we have a GitHub organization, organization GitHub, as a lot of companies do, where we manage our code. And in that organization, and in this one particularly, we have 771 repositories. Now that isn't all of our repositories. We actually have more than that. Actually, some of them I don't see, which I'm chasing some of our guys are like, would you give me read access to some of these things? So we probably have closer to 1,000 or more, but they're all over the place. These are the top languages here, but right behind it would be Java. There's a significant presence of Java, for example, which is probably next after that. And with all that, my boss, who's the CTO at Frontline, goes by Shri. He turns around and says to me, he's been here about a year at Frontline, so he turns around and says to me, since I've been here for about 4 years, he says, what are all these repositories? Which ones are products? Which ones are spikes or proof of concepts? Which ones are abandoned? You know, there's infrastructure stuff, and there's tooling, there's documentation, there's all kinds of things people use GitHub for, and they use branching different reasons and everything. And of course, one of Shri's interests are those repositories that are carrying product information. We want to make sure that that's quality code. And we want to be doing regular scanning and automation on them and make sure we kind of have a good handle on those things. So that's a real challenge. And so he turns to me and says, what is this stuff? And I'm like, I know some of it, but I certainly don't know 771 of them. So what do I do? So I think, well, how can I like figure this out? I can't like download them all on my machine and start reading through them. That's gonna be crazy. So I think, well, what does GitHub give me? How can I use GitHub to help me with this? So I go to the GitHub website and I look at the docs area and I see that they have a REST API. Like, oh, bonus, this is awesome. And in fact, even a bigger happy note is that they say right up front, you can use these to like get the data you need. Like, oh, that's just what I want. So that is awesome. So of course, when I think about that, I think, well, what would I do with that if I had REST API access to my repos? What would I do with it? And so I start thinking, well, let's see, I would want to have some kind of a tool where I can work with that data. I want to treat these repositories as data. I want to call those APIs. I want to look up my repos. I want to then figure out how to classify a repository as one of those kinds of things, a product, an infrastructure piece, a POC, tests, whatever. But it's got to be flexible rules. I've got to like play with it. I don't know yet what I'm going to find and what clues I'm going to have to look for in there that would tell me. So I may do some sampling and actually look at a repo in detail and say, now, how would I know that that's a test repo? And so I come up with some heuristics and then I would test it. And I need some flexible rules I can build to try that out. I need to gather information about like which ones are stale. If some of them are abandoned, how do I know that? And what can I look at in the repo to tell me that this is probably stale? And for those that I don't know what they are, I want to know, at least for those, I want to know who can I contact? Who can I call? Like, who was the last person that committed to this? Can I reach out to them and just say, hey Ben, you know, or Sheila or whatever, what is this repo? Can you explain this to me? So I may need some help, and that will then lead me to some more clues that then I will want to loop around and add to my classifier. And then, of course, in order to share that information with Shri and others, I need to produce some artifact that I can share with them and they can look at and consume, whether it be a CSV or that I would drop in with an Excel or just create an Excel spreadsheet directly that would give me a table of my repos and the classification information about that. So I need to work with this. I need a workbench where I can also, as I discover what things are, I want to turn around and write labels back into those repositories. If you're familiar with GitHub, you can put labels in there, and I can use that to kind of stamp how I've classified it once I'm confident I got it right. And I can push that back in there, and then we can use that in some of our other processes. For example, to run a scanner that would go through our repositories and pick up those that are product repositories and make sure we give those focus, right? And I need to also iterate on this stuff. But by the way, I don't want to trigger GitHub thresholds on my REST calls because I'm going to be making thousands of REST calls here, and the last thing I want is for GitHub to put a throttle on my calls because I'm presumably spamming their endpoints, right? So I got to be careful to be very stingy about when I'm actually going to have to go to and make that call there. So, you know, you say if you have a problem and you give it to a programmer, they write a program, right? And so this is the Clojure meetup, so I will tell you that Clojure is my tool of choice here. And you'll see why that was appropriate and why I use that and how I found value in that. So let's just take a little dip here and look at this. And this isn't a complete thing, but you can see kind of in a Clojure map format here, an EDN format, I have a sample of a GitHub repo that comes back from GitHub when I make a call to get information on a particular repo, and there's 74 keys that it puts out there, and as you can see as in this sampling here, many of those keys are actually themselves URLs to go get more content and to go deeper. It's actually a very rich API, and there's standard ways that API is managing volume, like pagination. Like you can get a certain page up to a certain number in one shot, so you don't have to chatter and go after you don't have to have 771 calls to get 771 repos. You can get a batch at a time, and there's a pagination protocol for that, and they apply that consistently with their APIs, which is very convenient. So with that information, armed with that information, I'm like, okay, I'm ready to jump in. So if you go to github.com tcooperfl Githubbing, you'll find this project, and it should be publicly out there. You should be able to go and get it, and you'll land and you'll see the README that looks like this. So I encourage you to play with this and send me your thoughts on this. It's a work in progress. It is a workbench. It's not complete in any way. It's a messy workbench, but it is one that is pragmatically kind of designed to be able to explore these GitHub repos and do some work with them. And of course, being the Clojure meetup, it's 100% Clojure. Woohoo, right? So I'm gonna walk into this some and show you some of the ways that I've addressed some of those issues that I mentioned earlier, how I do this, and how I've broken up the system to do that, so that I'm working in a REPL. I'm not building an application that I'm going to run from the command line, or I'm going to run as a web app or anything like that. I'm actually, the value of this is in the REPL because it's a workbench. It's not. It's something for me to explore and to come up with these things. So let me. Okay, so if you see, and if you open this up, you can see this. This is kind of the layout of my namespaces. And this is going to be kind of raw. For some of you that do this all the time, you're going to go, well, that's kind of naive. And I welcome any advice here. So please speak up in recommendations and suggestions. This is definitely a pragmatic approach here. So it's kind of sorted on the right, but if you do it more logically, the core namespace is my REPL home. That's where things are brought together, and that's where I spend my time in the REPL, and that gives me most of what I need right there. And I have other things, other namespaces brought in. And then there's a GitHub folder, and under that, there's the GitHub's namespaces are API, orgs, repos, and teams. And API is the one that has the code that does the primary gets, and actually does puts as well for those labels. And that implements like the pagination, that implements what happens if there's errors, how you do error handling, all that good stuff, to pull that information in based on URLs. And then the other ones, orgs, repos, and teams, these are the ones that implement. If you went to the GitHub documentation, you would see they organize their APIs on organizations, repositories, teams, and a couple others that I haven't had reason to do yet, but this is how I would continue to extend this out as I have need for other of those APIs in my exploration. I would then create appropriate namespaces that map to those areas, kind of following their lead. There's a config namespace here, which is just a lazy way of me providing some defaults and some hints that I learned that I put in there that or about that particular organization. In case of frontline, it'd be the frontline organization. In terms of what are some hints around the application names that we have that would be in the names of the repos that would give me a hint that these are related to that, and also some language defaults, some programming language defaults. And then there's the reports namespace, or the reports folder, which has namespaces within it that are, I have two that I have at the moment. One's called classification, one's sizing. The classification one is the one where I apply some kind of heuristic rules to try and classify and create a classification of a repo. And we'll take a look at that. It's a little bit of a poor man rule approach. When we talk about futures, I'll talk about some ideas I have to do that differently. But again, just enough to get the job done. And in the sizing side, we'll talk a little bit more about how the sizing information that GitHub gives you really is not what you think it is. And if you were actually to, like, for our example, we're looking at like, well, if we bring these repositories into Frontline and we host our GitHub, we use GitHub Enterprise and we host it, then we have to allocate space for all of our repos. How much space is that? If you look in GitHub, you'll underestimate it because they do a lot of kind of fancy compression, and they share things underneath the table that minimizes their space. If you were actually to clone all these repos locally, you'll take a bit more space than you think. And so I want to get a more accurate way to do that, and we'll see how I do that in the sizing namespace. Last of all, there's a set of export ones, and I just started with two, and that's enough. But if I need more, I can do more. But these are ways that I can take a report that I've created through one of these guys down here, and then turn around and preview it, or put it out in a CSV, or directly create an Excel spreadsheet with it that I can share with my colleagues and with Sri and others as we move forward on that. So if we were to summarize the flow, how I'd put this all together, I would go through this kind of workflow, this kind of work stream here. I would say I would go fetch some repos on an organization, Frontline, or on any other one. Then I would create a report I would take a small collection of those repos that I can work with, and I would then create either a classification report, a sizing report, or another one that I may create on my workbench with my tools. Would preview that, see, I may explore that, and then decide that I need to make some changes, like in a classifier, make some changes because I'm missing something or something's not quite right. I may make some deep dive looks at a few to see like, that's not quite right. And I would massage that, cycle around until I'm confident that I have something that's useful. It's not gonna be perfect, but it's useful. Then I might create a full report on the whole set of repos that I got, and export that in a form I can share with my colleagues. And you can see on the right, and we'll show you some more of this in detail, and we'll show you some live stuff on this as well. Up here, I'm creating at the top. I'm fetching repos, and you can see I'm kind of logging when I'm making calls. And in this case, it says fetched 100 plus items. It fetched the first 100 because I'm using a batch size of 100. And there's more than that in the repo set that I'm pulling from. And but I have it lazy, and we'll talk about how we do lazy here. So it's really just fetching the first 100, and it's not going to fetch anymore until I go and start walking through those. And then I call with that. I just take the first 3 of those repos, and I make my classification report, and I hang on to that. And this makes a bunch of calls, and there's ... here because I just clipped a lot of that out, but where it's making those deeper calls to find out what are the commits, what languages are being used. So it's diving into those URLs that are in that thing. And then here I'm previewing the report that I created, which only has 3 repos in it. I'm previewing it here, and the way my preview stuff works, again, very pragmatic. I can eyeball it or I can also copy it on the clipboard and go over to Excel and paste it in a cell, and because this is all tab based and it's designed to do this, it'll drop it nicely in Excel, and I can eyeball it there and play with it. Kind of low tech, but it's effective in me working as a workbench. So you guys understand the problem I have and my approach. We'll dive in deeper. But any questions or comments yet?
Looks pretty straightforward.
Very straightforward. All right. So let's take a little deeper dive. And I'm going to be showing you some code here and the results of that. We'll be walking through some of these things, and then at some point we'll be jumping into I will jump into the demo mode, and we'll actually jump into a REPL, and we can play with the stuff and make calls directly. So in the first one, as I mentioned earlier, when I fetch the repos, I have, by default, I just have a batch size of 100. And this particular organization I'm going after here has 171. And so it got just the first 100. And the other thing I want to do is make sure that if I make that call again, I don't go and make that, I don't end up making that REST call. It's because I'm on a workbench, I'm going to be retrying things. And so if I call to get the repos again, I don't want it to actually go and get that. And I don't want to actually make those REST calls because it's going to possibly increase my call count. And again, I don't want to get throttled. So does anybody tell me how I would do that? How I would not call that again? What would I use in Clojure?
An atom.
An atom?
That's what I'd use.
Okay. So, and how would an atom how would an atom allow me to not have to, I basically want a cache, right?
Yeah. If it's nil, then you haven't fetched it. If it's there.
Okay. Okay. What about something even more, even less intrusive? Like what if my function itself could remember what it was called with?
Memoization.
Ah, there's the word, memoization. The magic memoize. Yes, that. So we'll show you. I'll show you how hard it is to do that. I'm just kidding, because it's really easy. Before I jump into that, I'm a little out of order here. So before I jump into that, let me just step into the lazy get. Let me talk about how I do lazy. So as I mentioned, it went and got the first 100, but it kind of waited to get any more until it saw that I really needed it. Move my stuff around here. Okay, so this is the function that does the get, and I'm using the CLJ HTTP CLJ or CLG HTTP, kind of just the package that does pretty simple HTTP calls, request and response. And when I pass this a URL and some properties, the properties like what's the pagination size, what's my authorization token, what's my authorization username, that I'm going to be passing to the get of the HTTP client. When I get back, I immediately turn into JSON. Or sorry, I immediately turn into maps, and I'm passing. If you're familiar with a lot of this parsing, in this package I'm using Cheshire here, and true says to make the property names keywords instead of strings. So I say how many I got, and then in here I saying, well, unless I ask for a single page. If in my response I have a links and a next, kind of diving into the response, that means I got something back that says that there's more to come. I haven't been given all of it. There's actually more. And if you look at the GitHub documentation on how to do pagination, this is what you would look for. You would look to see that there's a links property at the top of the JSON result, and in there'll be a next property, and whose value is a URL to tell you how to get the next batch. So I catch that here, and if I see that there's something there, I concatenate the content I got so far, which would have been the first 100 or up to the first 100, and then I have a lazy sequence where I kind of recursively call myself to get the rest. And here where I'm actually going and getting that rest using that URL that they sent me. So this is how I implement the laziness, and whatever pagination I've used, I said 100, but and we'll see when we look in the code where that is, but it could be any number. This allows me to get chunks at a time and then make the call, and then the rest of my program not have to worry about the fact that it's coming in a piece at a time. That's the That's the magic of lazy here, right?
So
right.
memoization is automatically done by putting lazy seek there.
Yeah. With the lazy seek here, it's going to delay making that call again until when I'm actually walking through here. When I'm walking through the result that's returned, the content that's returned. When I hit that lazy seek, that's gonna trigger it to make that call to get the next 100, and then it's gonna return a sequence. It's gonna return a sequence of results here, which itself may end in a lazy seek if there's still more than 100 more.
Right. Okay. Yeah. Thank you. I was just making
but
sure.
Of course, from using it, I don't know. Right. From using it, I don't care because that's what lazy seeks do. So that was very nice. You have to be careful when you're doing stuff like this. Obviously, if you're doing things with like an open channel or something that may close, like but that's not the case here. This is totally open for me for that. So that really saves in making these REST calls. I can batch it but still treat it like I'm getting them all in one shot, but I'm not really. So let's talk about the memoize thing. So here is the code for memoize. So I defined that function called do GitHub get. Actually, I would have called it do get, but actually all the rest of my code calls do get, not do GitHub get. And this one line makes do GitHub get be memoize, meaning and I'm doing this as a def once because if I reload this namespace, I don't want to lose my cache. If you think about it, it's going to reassign this. So memoize takes a function, right? And it returns a function that when called, inspects whatever arguments you sent to it and uses that as a key and looks up based on the instance based on the function here that it has generated. It maintains a cache or a map effectively. I say effectively because that's what it does logically. Exactly what it does under the hood, I don't know for sure. They might optimize this more than this, but logically, it's basically keeping a map. And when you call it, it's remembering the arguments you sent to it. It's then turning around and calling the function that I gave it here. And whatever comes back from that function, it is taking that as a value and adding that as a value to the key that were the arguments in its own cache, so that the next time when you call it, it's going to check the arguments and see if it already has the answer. And if it does, it'll return that without having to call your function. Okay, and that's a beautiful thing for what I want to do, because I don't want to have to be worrying about in my workbench that I'm retrying things or that I'm exploring things. I don't have to be worrying about like I'm making more calls to GitHub and I may get throttled. Right, and frankly, the things I'm calling change very slowly. So I mean, GitHub, new repos or updates aren't that important to me in the context of my working session. So I'm not worried about it changing under me. So I'm okay with that because it becomes that value for the lifetime of my REPL session, unless I didn't do def once. If I just did def, then every time if I reloaded this namespace, it's going to redefine this and create a new function, and the other one will just get garbage collected away. And I don't want that to happen. So I'm using def once so that once it's defined, it won't be clobbered if I execute this again.
So as far as reloading this, I just saw a mention by Sean Corfield that he was sad that he had to restart his machine because he had a REPL session going for over 100 days. So
100 days for me may not be, there may actually be repository action that I don't want to miss out on, for 100 days. But yeah, so I mean, in that case, I close my session and restart it if I worry about that. But I'm not sure I'd want my machine locked up on memory that long either. For sure, given other things I do, but that's a good point.
Say a pragmatic question. What HTTP client did you settle on? There's a Google one, there's an Apache one.
It's the Well, when we look at the code, we'll look at the project CLJ. I think it's the HTTP. It's a CLJ HTTP package.
Okay. Yep.
Or HTTP CLJ, one of those two. I forget what. But it's.
So that wraps one of those two.
Yeah, it's pretty simple. Yeah, there's not much. It's not very heavy. And again, I don't really care about. I want simplicity in this workbench. I'm not concerned about performance or features, middleware and all that. So I just need a pretty simple HTTP client.
Gotcha.
Okay, so let's take a look. One other feature of this API namespace. So getJSON is actually a wrapper that ends up calling this do get. And so I put one more layer around this, and that is to deal with failures. So in that properties list or the properties map, I have the possibility that you could specify a failure function. And that failure function, if we get an exception in calling this REST endpoint, then if you have a failure function, I'm going to turn around and let it handle it. Otherwise, if you didn't have a failure function and it failed, then I'm going to throw that and let that bubble all the way up as a failure. And the reason I do that is that there are some times that I'll make a call. I want to make a call to a URL, but it's not present in there, and I don't want to deal with the exceptions. And so in some cases, I actually pass a failure function that is the what's that function? It provides the same answer all the time. Constantly, right? So constantly nil, So if I'm providing a function and I want the function to just ignore it, then I can pass one that just says fine, just ignore it. And other times I want to do something different. Also, the sanitize URL. If you noticed you probably didn't notice, but in the earlier slide, you can see that some of the URLs embedded in the GitHub response have a suffix in them that are URL parameters in curly brace syntax. And frankly, for the purposes that I'm doing, I'm not providing any of those. And so, but I want the URL up in front of that. So this is my way of basically grabbing everything up to I'm grabbing everything up to a curly brace, basically, and expecting at least something there. And that's what I'm using as my sanitize URL. So I'm kind of clipping off that section of URL parameters. That's what I want to really use. And so if it's there, I chip it off and then I use that instead. All right. So what does my default organization, my configuration look like? So I run this on frontline repos, but for the purpose of our discussion tonight, and in the GitHub implementation of Githubbing Toolkit, I'm using MongoDB, so as my organization. And as I was saying before, 171 repos. Well, it turns out MongoDB, if you go on GitHub and you do github.com/MongoDB, you will see their organization that's public, and it has 171 repositories in it. So that looked like a great one to work with for demonstrating how this Githubbing workbench would work. This tool bench would work. So I'm using that in my code and in my examples. And then when I use this with Frontline, I swap this one out with one that is the Frontline organization repos. Does that make sense? So in that file, I just have basically defined a config that says what's the organization name, or this is like the slug that you would use in a URL for github.com/MongoDB, and looking at what they have in there, and again, what I'll use, and you'll see in the classifiers, what I use is if there's certain products that are known, I will kind of list those here because I want to use those as cues that a repo that I have, if it has these things in it, are probably related to that particular product. So that's a hint, and I want to provide that. So as I looked at what was in Mongo, the Mongo's repositories, there's a number of things that they have there that probably fall under these categories. That I would want to like align the repos to these things or not those things, but basically use these to help guide my analysis. So once I grab a set of repositories by the fetch repos function that's in my repos namespace, here I'm creating a report from the first three. So this is the classification report, and what that does, and we'll dive into this when we get into the live stuff. I'll show you the code for this and get your feedback on it as well. But that's the one that will I'll take the first three repos and then turn around and create an analysis of those and return to me a result, which that report is actually the result of the analysis. And of course, I'm doing paginated, and all the low-level REST calls to do get are getting memoized. So if I do this once, and if I do it again, I won't get these logs because it'll give me the answer right away because it will have cached it. So some of the things that I can do, and you'll see that in the code when we have this, is I can fetch the languages for a particular repository. So if you looked at what comes back in a repository map or the JSON structure, there's a languages URL embedded in there, and so I implemented a function called fetch languages, which basically dives into that and then makes a call to that and pulls that back. And GitHub will tell you what it believes are the languages being used in that repository. This is a fairly new feature in GitHub, probably a year old or less. And they take a crack at how many, I think it's lines of code that they think are attributable to those languages in the repo. I will say though, that on the big numbers, they're probably right. On the smaller numbers, they're probably wrong. They're taking a guess. And often the ones that are the small ones, they may not have it quite right. They may be inferring it and getting it a little bit wrong. So I want to pay attention to the bigger numbers more than the small numbers. But in this case, for example, if I had fetched repos and filtered them to be just ones that had SDK in their name, then this is what this is from. SDKs. I could then map my collection of repos to that and call my add languages, which will fetch this structure out and add it into the repository map that it's been given. So my typical way to do this is I have this repository map that I got from GitHub, and as I do analysis and I do further analysis on it, I take my results and I add them in. I basically associate them into that map and return that, and then I work with that map, which now has been enriched with some more information, and then I can continue to use that and turn around that and export that, for example. So that's the path that I do it. If I add languages, if I map this add languages to this sequence of repos, then for example, I will take I will extract the languages that I've inserted in them. I can then, in here I'm doing a reduction. I'm doing merge with plus, which is going to basically match up all the Pythons in all of them and sum up the values in those and return the pairs. So and then I'm sorting this by basically decreasing lines, decreasing line count. So this is telling me the most to the least, the most prominent language to the least, the least often used across all these repos, like the sum of them. So this is the kind of stuff I'll do in the repo, in the REPL, to like understand what's in these particular repos. Make sense? Everybody with me? So I think to your question, Ben, I'm using the language to do something practical here, but I'm not really like writing big programs here. I'm in a workbench kind of to explore what I have. Another example is the real size on disk, and I think when we get into the code, you'll see this in more detail. But this first line up here, can somebody tell me what that line, how that line works, what it's doing? Given the repos is a sequence of these maps coming from GitHub. Anybody want to take a stab at that? Okay, so let's just break this down. So filter is going to be applying a function that when it's truthy will allow that repo through basically, and it will throw out ones that don't match this, that don't have a truthy value here, right? So I'm filtering my collection of repositories, and I'm going to catch that and define it in a variable here. But this is a function, and this refind is a regular expression find. It's part of the core library, and I'm giving it a regular expression, which is saying I want something that has in it SDK and then the end of the string. So I'm saying look for SDK as a suffix, right? And I'm going to be and I'm going to be looking at the name property of the map that I've been given to see if it has an SDK at the end, right? And so the percent sign, it was the variable. This is a shorthand of a function FN, right? So this is the parameter of that function. And filter then will take the repositories and one at a time, at least logically, right? You can think of it. It'll take one at a time. It'll take those repositories and call this function on it, which will be a map, and then it will access the name of that repository, and refind will return. It will return nil if it doesn't find this, and it will return, I think, the string if it finds it. I'm only care about the truthy value of this, so I only want to prune things that return nil. And filter will then use this as a predicate to say whether or not each of these repositories should be in the result that it hands back in a sequence. So the end result is my SDKs of all the repos I may have had here. It's only going to have the sequence of repositories that have a name that end in SDK. So a little bit of a heuristic there about which ones I'm going after. Turns out in MongoDB there are 3 of them that do that, and so I'm actually working with 3 of them here. And here I'm mapping my own add repo size function to this, and add repo size takes one of those repository maps and goes and sizes what it would, it figures out the real size on disk of that particular repository. And the way it does it is it actually creates a shell, it creates a sub-process and executes a shell to actually clone that to a temporary directory, and then look at the temporary directory created and count up the bytes in that directory to get an answer, and then delete that directory. So it's actually going off and doing all that, which turns out to be not too long. It's pretty quick. In this case, it did it on the three SDK repos that I found, and then it returns to me. I'm sorry. Then I'm actually looking at the results of that, and you can see this map is lazy because it returned to me the SDKs plus without doing anything. But the moment I try and show the results of mapping it, it actually goes off and makes the calls to do that, right? That's the lazy loading magic at work. And it returns me the clone result has been decorated into the repos, just showing me the result of the shell execution, because that's what my function did. And the other thing that it does is it also decorated it with size on disk. And so I take that same result, that same result of adding the repos, and I select out the name and the size on disk. And here I can see what each of them, what their size on disk is that I've actually confirmed by actually cloning them locally, counting the size myself, and then returning that. So a lot of stuff going on there, but it's very powerful to do that with not much code, as I'll show you in a little bit. All right, let's see. One more example before we're ready to look at real code. And this is getting branch information. So when you look at a repository, there can be many branches, and within a repo, within a Git repo. And the way that's shown up in what GitHub gives you is there's a branches property in the repo map that it gives you back. And that branches has a URL in it that when you follow that URL, you actually get another structure that has an array of JSON objects that each one represents a branch, and each of those has 3 properties in it. A commit identifier, the name of the branch, and whether it's a protected branch or not. So again, it's really simple to use that with the do-get stuff that I have, the tools I have around on my tool bench, right? And it's easy to write and add branches that, again, will take that repository that I give it, make the call, get the branches, and then decorate that back onto that map that I was given and return it, right? And enrich that map for me. In this case, I'm assigning it to a variable SDK plus B, just make up a name so I can hang on to it. Oops, I'm not quite ready for that. And then I write a little bit of code here just in the REPL to just show me those, show me the names of the branches for each of my repos that I have and that I'm working with. And I'm still working with the SDKs here, so there's 3 of them. And you can see there's logging when it actually went off and called to get the branches, because the do sequence and the print forced the evaluation of those. So in executing of this, it forced the evaluation, and the lazy evaluation got pushed through, and all the calls were actually made at the last possible minute, right, to make the rest calls, and they're all memoized. So if I did the same call again after I did this, you wouldn't see any of these logs because it wouldn't go off and do it again. It's all cached by the memoized do-get. And then this just kind of writes out what I told it to do, to print the repo and then the names of the branches, and blah, blah, blah that went off the bottom of the screen. Any questions or observations, recommendations? Okay, cries of fury, you want your money back? Thank you, Dan. All right. At this point, we're almost an hour into this, but I'm ready to move into the demo. But Mark or Yolanda, do you want to take a little break before we jump into this? Is this a good time, or how do you want to manage that?
Let's see. Yeah, it might be a good time to take a 5-minute break.
Dan says keep going. I thought we were taking a break before the discussion. So
this is kind of, yeah, okay. the discussion, I want that, yeah, because I would like the discussion to be part of the, as we get into the code, I think, it's not like I'm just going to present all this and then we're going to talk. I do want to have that kind of worked into the next demo part.
Oh, okay. Then why don't we take a 5-minute break? I'm going to pause the recording.
Okay. All right. You guys still see my screen? I think when you stopped the recording, it flipped something. I was like, you're seeing my time for a live demo filling the screen?
Yep.
Yes.
Good. Awesome. All right. All right. So let's step into the next piece here. All right. So you should see my IntelliJ environment here. And I first want to show you the def project so that it answers some of the questions about what I'm using here and why I'm using it. So I am, like I mentioned, I'm using Cheshire and just using the Clojure tools logging. It's maybe a little overkill for what I need right now, but if I take this further, I may be happy that I just started with that. I'm using the CLJ HTTP package, as we mentioned, and I also use Ancient often, and I don't know what everyone's experience is on this, but I have a number of Clojure projects kind of in a folder that I work on, like on the side, and every once in a while I just want to bring them up to date on the latest packages, and Ancient is a really handy way to do that. So if you want to learn more about Ancient, you can look that up, but it's a very nice way to upgrade. And it will run your tests as well to make sure that if anything's broken, you'll know about it, and then you can go back. I also use Kivit sometimes to, I'll run it on my code to, especially code that not just in so much workbench stuff, but if I'm doing a POC or if I'm doing some spikes, I may use that to keep my code clean and to remind me of good practices that I might be getting a little lazy on. I'm using OpenJDK 11. I'm using the JDK 9 variant, and the JVM ops just keeps it from yelling at me for using deprecated stuff. So that's just a little bit of a pragmatic item there. And I'm also setting up in my development environment, in my workbench, I'm setting up to prevent me from dumping everything out on the screen. So I'm limiting the print levels and the print length to a practical number. And I can always override that in the REPL if I want to, but that's just the way I start it then. So with that.
Quick question.
Mm-hmm.
So I wasn't sure if we might see Spectre as part of your dependency list. Did you find that the nesting of your maps was not so deep that it became a struggle to access and change things, in some complex, deeply nested map?
Not really, not yet. I mean, if I found that, I would go down that path, but I'm using just enough to get the job done. And frankly, I'm getting pretty flat structures from GitHub, and where they nest, they use URLs to do that. I don't have to go really deep on that for this, for dealing with GitHub. So I really haven't had to bring in any big guns on that. Same thing for, like, I'm not doing any spec stuff. I'm not, I'm really dealing with these things as pretty primitive maps, and that seems to do the trick for me. But I'm certainly open to, as you see in a code opportunity for me to do much better than what I'm doing, I'm ready to take notes. I have my notebook all here ready to go. So,
well, maybe the lesson here is that maps, plain old maps, gets you a long way.
Certainly does. And actually, there's one thing we'll look into where I played around with I have a def record. I have a def records in here, and I played around with using multi-methods, or maybe using protocols and def protocol, or even def types. But def types I rolled out pretty quick. And as I went down that path, I started to ask myself, is it worth it? Like, what value is that giving me? And I ended up back at a simple def record in one place, and being good with that for now, But like you say, you can do a lot with, like, the primitive stuff here. You don't have to, and probably Dan is happy to hear this, right, Dan? That, you can do a lot with just the primitive stuff that's in there, and then you can explore as needed to get more benefits, especially if you have people looking over your shoulder that know this deeper than you do, as I view you guys. Give me some advice on how I can do better with the stuff I'm doing.
Excellent.
All right, so let's go into, here's the configuration. Let me zoom that in a little bit. There's a configuration for MongoDB, and what I'm using. And there's a name MongoDB, there's a products, and then these were the top languages that I saw in there that I want to use as my guidance about things that are probably product repos. And again, we saw in the slides how you can find out what are the most used languages. and so I did that. Using that result, I then turned out and just I captured those top items and I put them in here because I want to use those in my classifier. Okay, yeah, I've done that, Tom, too. So I've tried to use a package, like I want to try and use this package. So let's go into core where most of my work is done here, and zoom ourselves in here. And just when I'm working on a workbench, I will often just put a comment in here with code that I usually want to work with and that I use often, and I can just kind of grab that and run with that. So let me for example, I can grab that, I can execute that, and I'm pulling this in. By the way, I'm using IntelliJ, I'm using Cursive, the Cursive plugin, which gives me keyboard shortcuts and structure editing and a lot of those good things, and lets me manage my REPL in a window over here as well. So here I just made a call, and in fetch repos goes and gets those. By default, we'll get the repos by my configuration. I can override that, can provide arguments that we'll use instead. I can go get somebody else's repos. But for convenience, I'm using my configuration to manage that. So it just went out and got the first 100. And it's going to be lazy about getting the next 71, or unless MongoDB added another repo since I've done this, there's going to be 171. I also wrote a load and save that just saves these. Well, I could save the repos in a file name, and then I could load them back up again, just in case I'm in a state where I've decorated things a lot, and I don't want to lose that. And I want to exit my REPL session, and I want to save that state, and then next time come in and pull that in and go from there. Of course, I will lose my cache, and if I make REST calls, they'll be called again. But I may want to save my work that way, so I made that right away. So let me grab a couple of these, and we'll make my R1. So let's just take my repos. So my first repo, actually I just look at the name of it. Oops. So the Mongo QA is the first one I got here, but of all the ones I have, and if I were to count all of them, of course, that's going to trigger it having to lazily go out and get the rest of them. But I actually will do that because there's only one more call it has to make to do that, I believe. Because there's only 171 of them. There's the call for the next 71, and sure enough, I got 171 of them, right? So now my repos is the fully fetched set. Of course, I didn't have to do that. When I process it in my report, it's going to end up walking them all, and that would have forced it as well. But as you might notice, if I were to go again and call repos fetch repos, it just does that, but it didn't make any calls to rest, and didn't make any rest calls, because that's our friend Memoize that work for us. Thank you very much, Memoize. And if I were to then create this classy report, that's just going to go off, and it has to do some more calls to go deeper and get some more information to do that. And so it's going to do that for a bunch of them, and we'll let that guy just go off and do that. I probably shouldn't have done it on all of them. That was probably a mistake, but because it's going to do a lot of them. All right, so while it's going off and doing that, let's go take a look at reports. We went through the API and repos and stuff. So let me show you how I do reports, because I think that's where it gets kind of interesting. This is where I struggled a bit about, like, how deep should I go here? I want to have multiple reports, and I want them to be giving me a result back, which is in a manner that I'll have the name of the report, and I want to have heading information for kind of a tabular report. And then I want the data to be a sequence of maps that I've decorated from the repos, right? That would start out as the repo maps, and then I've decorated it through analysis with more information. I've enriched it. So that's what I want my reports to use, because I want my exporters to depend upon that. That's my interface to that's all I really need for my exporters to work. So do I need to make a def record for each of my reports? Do I need to make just one def record and then create that from the reports? And that's kind of where I ended up. Or do I create a protocol and have them all implement it? Well, it's mostly on the create, so it's not like I have something to put a protocol on. I haven't got it yet, right? And frankly, all I need them to have is to be able to access the name, the headings, and the data. So it's a little overkill for me to use protocols for that. That's kind of how I arrived at that decision. So when I create a report, after I've done the analysis, I create the report with it. I provide the name, headings, and data, and I just basically put it in this form. But have you guys ever used the pre and post assertions?
Sure.
Okay, so this is also my friend. I use this a lot, and in this case, I'm making sure that so when this map appears right after your argument list here, your parameter list, it basically defines some tests to be executed on the way in, and then it can also put post, which would be tests to execute on the way out on the result. And on the way in, you have access to the parameters. On the way out, you have the default percent variable to use as that will be bound to the result of your function. So on the way out, you can check that some properties are true of what it returned. In this case, I want to make sure that headings and data are correct. So the way this works is, again, data is going to be a sequence of maps that are the enriched repository map that I got from GitHub. And then what headings needs to be is it needs to be I need to get the sequence on here right, because my report has to have an ordered column list, right? But yet a map is not ordered, right? I mean, I'm not doing sorted maps and like this. It's not ordered. So the ordering has to come from the heading. So what my heading is it's a vector of pairs, and the pairs are, the first of the pair is the title of the column, and the second of the pair is the key in the map that will give me the value. And I need to make sure that these maps have values for all the headings. If that makes sense. So my precondition, this is a predicate. This thing is to be a predicate, and it will complain if this isn't true, is every row in my data, every map in that sequence I got in my data has to satisfy this. Sorry, the whole thing is a predicate. Has to satisfy this predicate. This is the way every works, is that this needs to be a function that when provided a value, which will be provided every one of these values. So when it's provided a map, it's going to give a truthy value if every is going to make sure that everything is truthy, and it will fail if it finds any one of them that isn't truthy. So what is that? Well, I need to make sure that so I need to take my headings, that vector of pairs. I need to extract just the keys out of it, which is what map second headings will do for me. It'll take the second item of each of those pairs, which are the keys, and I pass that to create validator. And create validator says, okay, I got keys. I need to. This is actually this is going to return the predicate function. So this is going to return a function that says, okay, given those keys, I'm going to get the keys out of the row, out of that repo, that enriched repo. I'm going to get the keys out of there, and I'm going to turn that into a set, which makes it a predicate function, because a set, when presented with an argument, will tell you whether that argument is in the set. That makes sense? So I'm going to say, make sure that every one of the keys from my heading is found in the set of keys in the row. And this down here says I'm going to do it for every row. So I am thoroughly running through the entire list, making sure that every row has a value for each heading. That makes sense? All right. That was a fun bit of little Clojure work to do there, I must say. All right.
Now this, a quick comment, I guess this would seem to be a classic application of Clojure spec, although I'm not totally sure it's as dynamic as you'd want it to be for a workbench.
Well, Clojure spec, if I understand, would ensure that the structure was right.
Right.
I'm actually doing a relationship test here, making sure that the relationship between these two structures is as I'm prescribing here. Every key, everything in the headers has a corresponding value in all the maps.
Right. I believe spec is extensible to relationships, but it might be more effort than it's worth.
Yeah, well, it looks like it wouldn't know what the keys are until it gets the thing. And
right.
So I think I was wondering why it's not spec, but that makes sense. I don't think you can make spec to check for keys that you don't have yet.
It's true. Yeah, my different reports will have different headers. And so when I create a report, I'm provided what those headings are, and it'll be different for different things. That's my anticipation. So this is just a check on myself to make sure that I don't get things screwed up, right? And that highlights a really interesting point in that, sometimes the machinery to bring in to do something, even though it could do it, you may be better off doing it with a hand tool, right? Doing it with something simple that just uses a primitive. That's always a trade-off, right? And that's kind of goes back to why I kind of settled at using just def record. But I definitely will take a look. I will say, and another reason why I didn't use spec is that I'm not really as experienced with spec as I want to be here. So I'm not as aware of what its power is. So that's something for me to take note of.
But it looks like it wouldn't be able to do the thing that you wanted it to do. At least
because I have to have literals for the.
Because it doesn't know, it can check a specific condition. So if you give it a set of keys, of course you can check that it has those keys, but it needs to get the keys from the thing itself. And I'm not sure, I suppose by some clever function, I don't know. Tom in the chat also didn't think it could do it. So I think it might not be possible to do it with spec. I'm not 100% sure, but I think Mark, Tom, and I convinced each other that we can.
well, actually, this leads me to another question and maybe observation. So I didn't notice any diffing capability, and I had written an API harvester like this to do some analysis. In my case, it was vulnerability scanning reports. And a valuable thing for me was to know what had changed between sessions. And did you implement any kind of a diffing capability, notifications on change, that kind of stuff? And I guess that would be another place where spec might make sense in that once you had established the set of keys for your headers, then that should remain stable. And if something changes, you want to know. Maybe you do. I mean, for your case, it doesn't quite seem as important, but.
Yeah, that's actually interesting. And some of the things when I talk about the futures of what I might want to go with this, I may want to be looking at time series, changes of a repo over time. And that's where that might be more valuable. But that's something to think about. I didn't really see any need on my workbench so far for any diffing tools. I have hammers and screwdrivers, but I don't have a differ. But if I needed it, I would. That might be something to look at.
So you haven't been asked for any sort of like activity reports, growth of the total repo size, or commits per month or week or whatever.
No, I haven't. I could be asked that, but frankly, there are companies out there that do this, and and
Yes.
Frontline has engaged some of those companies. So getting kind of some of the bigger guns in there to do that kind of stuff. There's other solutions for that, but certainly that's something I could be asked for, but I kind of doubt I will, because I think by identifying things, we're then taking it to the next level with deeper analysis with some some more commercial tools.
Cool.
Okay, let's take a look at one of the classification rule, which is probably the interesting one that uses this. And let me go down the bottom so you can see how I prepare it, and then I'll show you the rules. And whoops, I'll show you the rules and how I do it. Make it readable here for you guys. All right, I'm working on a 27-inch screen, so if you guys are like seeing this really small, please speak up because it's not small to me in the screen.
It would be nice to make it a little bigger for my screen.
A little bigger.
A
okay.
little bit.
All right.
Yeah, this is great.
Very good. Okay. So let's just move this guy over here a little bit. And I usually keep a doc view up here. That lets me, it reminds me of what things are. So let's get down to the bottom here. So here's my headings, like I was mentioning. It's a vector of pairs. And I probably would have been helpful if I showed you that first, huh? And then here's where I create the report, the classification report. I pass those headings, and then the repos that I've been provided, I call prepared data, which is defined above. And if I got given any repos, I'm just going to go fetch the default configuration repos and go with that. So my hand tools kind of bring their own data in some ways to make it simpler for if I'm typing things a lot. All right, Ben, thank you. So what does prepared data do? I'm mapping across those repos, and I'm classifying the repo with a classifier, which we'll see above, and I'm returning a map, which is information that I have about. I'm to return a map here for that I'm going to be getting information, pulling information from the repo and pulling information from the classification that I made to return. Basically a sequence of these maps in response to the repos I've been given. So, and this corresponds to the headers, the headings you see below. These are the keys for those. So I'm basically computing answers for each row here, based on a combination of the repository map I've been given and my classification that I've made on this thing. So some of the things are pretty obvious. I'm just diving into the repo map to get the owner and the login inside the owner, and I'm making that's the name of the org. That would be MongoDB, for example. And then getting the name out of the map I got from GitHub. And here's where if I'm working with a map that I've already decorated with our size on disk, I'm going to put that in there. Otherwise, I'm going to leave it as an empty string. Same with the branches. If I've gotten the branches yet, I'll use that. Otherwise, I'll give an empty answer on that. And then what I've gotten from classification up here is a map that is a rule that has a name and a classification, and I'll show you what else is on it. That I'm gonna put that in there. The name of the rule that the classifier found, the classification, whether it thought it was a product or a tool or whatever it thought it was, I'll put that in there. If there's a description from the repo, I'll include that. The dominant language, I have a function top language, which is going to pull out what is the top language, the largest language used in this repo, which you can imagine based on what we've talked about earlier, how you can find that, and we can look at that above. Actually, you can see up here if you want to get a cheat sheet on that. It's stale if it hasn't been updated in 2 years. It's just my arbitrary stale criteria. I put the dates in when it's been pushed and updated, and who the last committer is. I pull that out as well. And a couple other pieces. These are the things I want to put in my report. So this is constructing one row in my report table. The interesting thing is to classify here. So, and this is my poor man classifier. All right. So let me first show you what a rule is, and then I'll show you how I use them. So my rules are just a vector here of maps that says what the rule name is, what its description is for my own kind of debugging, and then a test function that says whether the rule applies. And then topics that will also, if there are topics on that repository, if any of these topics are in that repository, that would also be an indication this rule applies. And then the resulting name of the classification, how I've classified this repo, if this rule applies, would be the fifth item down here. So documentation, if the name it starts with docs, and some of this is really heuristic based on some of the frontline stuff. So if this seems a little odd, this is, some of these are bleeding all over from what we do and what I found in looking at the 700 and some things in frontline. And it may not all apply generally across the board. It'd be neat to do some project to figure out, like with machine learning or something, to find out what are the most common characteristics of these things. If I had a sample set I could work with. But again, this is part of the massaging of the workbench, that I try stuff out, see what it is, come back and forth. If it has topics on it or labels in it that have documentation, docs, or design in there somewhere, then that would also be an indication. So it's pretty lame, but that catches some number of things. And the way I apply this is sequentially. So the first one it hits, I go with that. And so anything that doesn't hit this one, I'll try on the next one and try the next one. And we'll see that below. I'm simply walking through and doing a sum, SOME, right? That says find the first one that matches, and that's the one I'm going to go with. So a test repo that's now a little more involved if the description of the repo contains test or QA or mock, or sorry, if its name contains those things. And contain string is one of my functions that basically does what you might think it does. It just checks to see if these are in that name anywhere. Or in the description, if the description provided in the repository, if it has the word test in it or automation, that's also a clue that this might be a test. And from massaging it, I kind of arrived at these clues that are pretty reliable. They're not perfect, but they're pretty reliable, at least in the frontline code. So anyways, it goes on: infrastructure, tools and utilities, looking at name and description, looking at topics. Here, it's a sandbox project, if either I see words like sandbox, POC, prototype, skunk, spike in the name, or something similar to that in description, or it's been labeled with something like that, then that tells me it's a sandbox project. Internal projects, frontline has a few more things that I can put in here that I would use for that. Probably a more interesting one is when I get down to has source code. So here I'm actually looking at the languages that GitHub says is in there. In an earlier version of this, I actually dived into the files and looked for the clues myself. But now that GitHub does that for me, I ripped that code out. Now I'm just having it tell me. But then I'm comparing that to see that if it intersects the languages which I've associated in the configuration that I think are the important languages of this particular organization, if it intersects with that, then I say, yes, that's probably source code. This is probably a source code repo. Again, GitHub isn't really reliable on some of the smaller count ones. And so I want to get rid of that noise. And that's partly why I look at the major ones to do that. So if there's some in there that intersect on that, then that gives me an indication this is a product repo, probably, right? Okay, so has scripts. I'm just here looking for scripting languages, and if we look above here, I'm removing scripting languages from consideration. First of all, let's look above at the languages stuff just to make sure we understand what's going on there. So the product names are just the products coming out of the configuration. And the scripting languages, I'm actually calling out specifically here. And I'm just listing these and I'm turning them into keywords. But I'm managing the strings when I created them. These are languages that GitHub classifies that I think these all would, I would consider them kind of infrastructure kind of code, which I'm arbitrarily saying is probably not the product language. And again, because it's later in the rules, the product language will catch it first if it is a product language. So this is used as scripting languages for that purpose. If that makes any sense. So let me scroll back down. Oh, there's my days between. I have a couple primitives up here to help me do some calculations. So I'm calling into Java classes here to give me some calculations to tell me how long what durations are between things that let me determine how old the stuff is. Let me scroll back down here. Finally, the last rule is like manually inspect. Like, okay, none of my rules applied. I don't know what this thing is. and my test function is constantly true. Right? So constantly true, we know will return you a function that whatever parameters you send it, it will always just say true. Right? So it's a nice thing about this. You can, I've used this often. I'm sure you all do as an idiom. Like if you have a function that just uses a predicate, sometimes rather than testing for an end case, whatever, you put a constantly true in the right place, and that will make sure that you've captured the remaining and you've scooped them up. Right? So everything will get a classification. This one will ensure that if it gets this far, it's going to get this one if it didn't get any other ones.
Quick question.
And this one, pardon me?
Sorry, I had a quick question about classification there.
Mm-hmm.
So if you wind up with a manually inspect, and now you've gone in and taken a look at the repo and you understand what it is, can you then capture that intelligence so that, you know, in a future run, it uses the human-based classification instead of the heuristics? Yeah,
well, I do that with poor man machine learning, right? Now I say that in jest a bit, because if I had a good sample set and a learning set to work from, I may be looking for things kind of to correlate, right? But as a workbench, what I do is I take a look at that repository, go, oh, it's a documentation repository, obviously based on looking at the files inside it and stuff, and go, okay, or maybe I've talked to a committer and said, what is this thing? And they explain it to me. Then I go, okay, how would I know that? How would I know that? What's the clue I might find in there? And I'll find something in there that would indicate that, you know what? And then I'll try some. I'll go up above and I'll say, well, it's a documentation thing. Well, then what did I miss? So why didn't this, where is it? Sorry about the scrolling here. Why didn't my documentation one catch that? Well, it doesn't start with docs. It starts with explanation or something. You know, I mean, I find some other clue, right, and then I go ahead and edit this, and I add that in, and I try it, and I try it on some repositories, and I will then and see what it catches. And it will catch the one that I just found, but see if it catches some false positives too. And that's part of the cycle. Then I'll go back through and go, okay, that was too broad of a brush. I need to like get more refined. You do this a number of times, and that's why some of these came out down here, for example, in the infrastructure repo. Some of these things you wouldn't necessarily think of, but these came out of my iterating with frontline code to say, what are the infrastructure repos? And through that iteration, I found like, oh, Terraform, that's the key, because these guys are doing Terraform scripts, or they actually use the word cookbook to talk about this, you know, like a playbook or something. If someone might say playbook, and I may put playbook in, or these were chef scripts, or this is a Kubernetes thing. And so some of these conventions that I discover, I can then work that back into the rules and then try them out and see if I've gotten an improved set, if I feel more comfortable with this. It's just an iterative process. Does that help answer that, Mark? Yeah, it makes a lot of sense that, you know, you keep improving the classifier based on things that it isn't able to automatically classify. I was just wondering if there was, say you had something that was really anomalous and it misclassifies it. Great question. And you really don't want to tweak your rule, because the rule is really pretty good except for this one oddball. So, and you would want some literal overrides for these edge cases. So here's how I do that. If I figure out what it is, I can go ahead and add that topic to it manually. I can go to the repository and update it and add that topic to it. And so my classifier first checks to see if there's a topic match. And if there's a topic match, then that overrides things. Exactly. Okay, great. Yeah. Yeah.
Very useful.
Yeah, so you got it. That's how this works, right? Let's see what else. So I will show you the sizing one too, and then we'll look at some of the results here. This guy's all well done anyways. So my sizing report, just like the other one, is I have headings, and in this case, I only have these headings, and I want to create a sequence of maps that just have these keys, and then I'm going to make my report be a report that's going to be based on this, the same as you saw on the other one. And here again, I'm using the fact that I have a single def record for report that takes this way, and the create function that I'm using, the create report checks to make sure my headings and my rows are have this relationship with them. There's a dependency on them, so that will just catch if I make a mistake of saying it the wrong stuff. And the prepared data here, just the pattern. I use the same pattern here. The prepared data here actually goes in here, and it adds the repo size, it adds the branches, it then formats that row, and we can look at what each of those things are. The format row basically is the one that actually forms that final structure that I want to report on, and then I put that all together into a vector, right? And because if you're familiar with this is actually not forming these ahead of time, but it's actually doing it's doing this one at a time line through. It's doing it's a transducer. So I'm not forming all these things and then making yet another one and then making another one. It's actually sequencing them through the whole composite function, and these transducers are applying one at a time through them one at a time. So like the magic of this stuff, right? It's not going to actually be creating whole lists and then passing them through there, or whole vectors and passing them through. It's actually going to be optimizing the memory and doing this much more efficiently. So that was my one little dive into using transducers for this, which I'm always looking for opportunity to justify doing that, right? Because anyone that reads my code that's doesn't really have a deep understanding of Clojure, they could be baffled by some things, and so I have to always balance like making it readable as well. Anyways, the key thing here I'll get into is the size thing, adding repo size. So here, again, giving a repo map, I'm going to go off and find the temp directory. I'm going to create a new directory under it that follows the name of the repo. I'm then going to execute a subshell that's going to do a git clone on that URL that's in there. It's actually going to like clone it using the git, the git program, right, as a shell command here, and it's going to create that whole structure. And then I'm going to go and using this little size function I wrote, it's going to just recursively walk down that tree and collect up the size, the length of each of the files in bytes, and sum all that up and give me a total number of bytes. And then I'm going to log what I did here, and then I'm going to go off and I'm going to remove that whole directory structure that I just created, that I just cloned, throw it away, and then I'm going to merge into that. This is where I'm going to decorate this repo map. I'm going to add in the clone result, which is the result of the execution of the shell process, and then I'm also going to add in the result of summing up the bytes, and that's going to add into that map for me. And now you can see down below, I'm going to make use of that on the size on disk. Actually, I don't even use the result in my report, but that's kind of for my own debugging if something went wrong. I can be able to see that. So again, the report doesn't have to have. There can be entries in the map that aren't in the headings. That's okay. That's extra stuff, right? That's whose law is that, right? That you want to be stingy with what you require and generous with what you get. How's that go?
Yeah, that's like an internet RFC, I think.
Yeah, it starts with a P. Somebody's rule, somebody's law, right?
Yeah. Postal, right?
Yeah, that's the one. Yeah. All right. Okay. So if I go over here and I say Class C report reports. That's it, right? I just went and did all that we just did. It just applied all that stuff. I can export that. So I can export that. I can CSV preview it. And that's going to show me, if I were to drop that into a spreadsheet, that's going to show me, each row, what it came up with. But let me do the Julia Child method here. If I were to create an Excel spreadsheet for that, and watch as the fingers never leave the hands. How's that go? As I switch over to this view, you guys seeing my spreadsheet?
Yep.
Okay, so this is where I've taken that up and pulled up into a spreadsheet. And what I've done is I've taken what it created and I basically formatted the first line and I added an auto filter on it in Excel. So, and this is the result of running this on MongoDB on their 171 repos. And as you can see, the classification role is the name of the rule that applied, and then the classification of that repo is what it put here. And you can see that some were documentation, they found some empty ones, surprisingly. Some were examples, infrastructure, product, and test. Oh, sorry, and there's more, and unclassified and utilities. So a bunch of rules, separated out these repos. Like Shri asked me at the beginning, which ones are product, which ones are junk, which ones are whatever, and not all the rules found stuff, but in the Mongo organization, but it did break it out into a lot of them. So that's convenient. If I were to say, what my practice would be then to say, let me just find the ones that I couldn't find, the unclassified, that catch-all at the end that had the constantly true. Like, what was that? So I would find that, and I get the spinning ball. Oh, there it is. Oh, sorry, not infrastructure. I don't care about that. All right, find me the unclassified, guys. Oh, come on, you're killing me here. Unclassified. All right, are we good with unclassified? All right, so unclassified. So here I would look for those in the frontline code and say, all right, these guys are unclassified. My rules couldn't distinguish what those things were. There weren't any clues in them. Here's Haskell representation, sketch symbol libraries, pilot program. So is the word pilot a clue? Is the word pilot a clue? If the CVE list thing, I would at this point I would jump into the GitHub repo CVE list in MongoDB, and I would take a look at it and say, do I understand what this is? Is this in fact some skunkworks or POC? Is the word pilot a clue for that? It's not stale. The first one looks pretty old. It hasn't been modified for 2 years apparently. So maybe I could just, not worry about that. That's stale. But the other two, I needed to figure out what they are. And that's what I might do. And then I might turn around and take the word pilot and put it back in that rule that says it's a POC. And the next time I run, and then run this again, and then this guy should now be classified as a POC or skunkworks or whatever I called it, whatever the classification was for that. And that's the iteration that I would go through to figure this stuff out. Ultimately, if I didn't know, interesting, like there was no information here on committer, and actually, I think I only do this for product. I think that's a mistake. I shouldn't do it only for product. I should fix that. See, look at that. I also find bugs in my own code, improvements as I explain it. We all do that, right? You explain your code, and that in doing so, you find all kinds of improvements to make.
Every time.
So over here, I can, if it's a frontline employee, I can have access to them, and I can go talk to Mike and say, hey, Mike, what is this repo? If I didn't believe it, right? But you can see there's lots of it gives me lots of information, and I can sort and answer those questions for Shri or anybody else. All right, let me go back to Any more questions, or anyone you want to dive in any more code before I wrap up with kind of the results here? All right, then we will attempt to move forward here. So why do I use Clojure for this? The REPL, what more can I say, right? The ideal workbench the ideal workbench environment. Tom, you mentioned that you didn't know GitHub had this API. Actually, there's a lot of APIs out there for stuff. There's a lot of free stuff. The whole semantic web world has kind of created a push. A lot of government's information is available through APIs for free, but also a lot of companies have an API portal and API documentation on their sites. If you look at any of the Atlassian tools, for example, they have a very rich API to go and programmatically do almost everything you could do on the UI. It's now more common that tools and GUI-based applications or UI-based applications are API-driven, and those APIs are often made public to you. It may be you have to have an account to do them. Sometimes you're throttled or you're limited in what you could do from a free account because they don't want to have denial of service attacks and stuff like that. But there's a ton out there. You'd be surprised. Of course, easy caching on a metered API. So the memoize is just a really great little tool to have in your tool bag and in your pocket to be able to deal with this kind of situation. I can be on that workbench and iterating on this a lot and not worry about that I'm incurring any more cost in my calls, right? Or being metered on it, which is very cool. And of course, the flexible data manipulation, I'm enriching maps as my practice. So I'm not creating new stuff and then trying to correlate it. I just add to what I have, and I add to it, and I add to it, and then I use pieces of it for my report. And that's a very nice flow to go through with this. And I'm sure for those of you that use this in a more discovery mechanism, I'm sure you all concur that's. But if you have better ideas too, please let me know. This is how I found it useful. Some things I want to look at doing next with this. One is I really would love to get more visualization going on here, and we alluded to that a little bit in the discussion of doing diffs or other ways that we can look at sequences or time sequences. If you ever look up Gorse, I don't know if they pronounce it Gorse. It's like Gorse.io. It's some really amazing and fascinating visualization and kind of making a movie out of the lifetime of a repo and how a repo evolves. And it's really slick. It's just really cool, and it's pretty straightforward internally in how it's done. I would love to build that into some tools where I'm managing Clojure data structures. That would be really cool. The other thing is Clara rules. If you've ever used forward chaining production rules systems, Clara rules is out there as a package. That's a Clojure. It's written in Clojure, and it implements the forward chaining ready algorithm or the read algorithm. I use it in another one of my tools that I use that inspects JSON schemas. Another tool for another talk for another time. But I look at JSON schemas, and I look for schemas following conventions that we have for some of our models, and I use Clara rules for that. And there's probably maybe 50 rules in it. And it's not really inferencing chaining very much. It's mostly the Blackboard model where you have the gremlins looking at the Blackboard and all coming and making some changes and making some recommendations. So it's that kind of approach as opposed to a long chain of transformations that often is done in a forward chaining language. But as I look at my classifier, I'm thinking, could I make some leverage out of and some clarity out of using Clara rules and just maybe as a challenge to see if I can do it and if it would fit. And then, of course, your suggestions that you have, I would want to try that out too. So that's what I have for this discussion. It's supposed to say thank you. What happened to thank you? Sorry, I'm supposed to say thank you. That's what I have for our presentation today. I welcome any feedback or comment, or you can always look me up and send me email at tom.cooper or tcooper@frontlineed.com.
All right, well, thank you so much, Tom. Let's open it up to everyone if they have any questions or comments, and we can kind of seamlessly merge into a sort of informal post meetup chat session for those who want to stay longer. So yeah, so go ahead, folks. Any additional questions or observations for Tom?
I think I'd like to talk just on this last thing, the Clojure rules. I've never heard of them.
Oh, the Clojure rules?
Yeah.
Yeah, it's pretty cool. I have a background, like I have Ops 5 listed here, right? That Ops 5 was the kind of the first, well, maybe the second. There was an Ops 4 and actually something before that, but Ops 5 was probably the first commercially successful read algorithm production system matcher. When I was at Carnegie Mellon, I worked with the guys that did this. Charles Forgy is his thesis, his master's thesis, or his PhD thesis, I believe, at Carnegie Mellon was around that algorithm, and he built the original languages on this, and he built it in Lisp. It was a Lisp application. I was at CMU at that time as an undergraduate, and took that to Digital Equipment Corporation, where we used that language to build the first kind of industrial expert systems that were kind of at a major scale. Where we had thousands of rules, and they were configuring VAX computers and stuff like that. So, but that algorithm has been improved upon various times over the years, and has spawned things like JES and CLIPS. I think NASA did CLIPS from that, and then J rules, and there's a few other rule systems that also added backward chaining in and brought some unification logic into that. Whereas Ops 5 was just purely a forward chaining system. And Clojure rules is an implementation of that fundamental algorithm, the fundamental read algorithm, probably with some of its own optimizations, I'm not sure, that allows you to do forward chaining in that style, so that their condition action rules build into a discrimination network rather than being sequentially executed. They're built into discrimination networks. You can think of all the clauses, all the conditional clauses being combined and optimized by sharing in a network, and you pour your changes in the top, and they bubble through until they hit leaves, and then those leaves are the actions, and then you have to determine which one you're going to execute, and then that creates another change which goes back into the top of the tree, kind of, and it bubbles down. So it's made to be optimal on incremental change, and then it maintains match state. In that network, in that discrimination network, it maintains match state, which makes it really efficient for rapidly having a lot of rules fire that each one creates incremental change on the entire state of things. It's pretty cool, but again, it's very usable and it's very idiomatic. The Clojure rules guys did a great job in making a really idiomatic a package for that to treat these as data structures.
Nice.
Sounds very cool. So I just wanted to make a comment. Well, first of all, thank you so much for presenting this topic. It looks like a really useful library. A lot of people could get a lot of mileage out of this. I think you were too humble in your Clojure level of expertise. I saw lots of good practices, memoization and transducers, and you avoided a lot of the pitfalls of newbies, either trying to use all the more obscure parts of the language, good use of libraries. So I think it's excellent package.
Great. Well, I hope everyone got something out of this and enjoyed it. And I definitely enjoyed having the interaction with you guys on this this kind of skunkworks project that I was using Clojure for.
Yeah, thank you very much. So would it be okay to turn off the recording now?
Yep.